Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to look at a 2012 Chevy Equinox. This vehicle is experiencing rich running codes, and so really the first thing we need to do is connect a scan tool to this vehicle and go drive the car to gather some data so we can properly troubleshoot the car. So let's get a scan tool connected. Now we have our eSCAN connected to the car. Let's take a look at some of the data. We can see that we're rich and lean, so that means we have fuel control. We're at a centered fuel, but our long-term trim is red, which means we have way too much trim, and our total trim is red. So we have too much trim on the vehicle. Now our vacuum is okay, charge is okay, and we've warmed up in time. We have 2 codes set, and no one has cleared the codes on this car. The monitors have been completed. So that's always great to look at. So now we can come over here and we see that we're too rich on bank 1, and that's why I'm here. So the shop inspired me to take a look at this car because of the rich running condition. So let's look at the evap system. We have a large leak. Now I don't want to get caught up in the leak. And there's always a possibility that when the shop was looking for this, a good shop would have pulled the purge control. And when I pull the purge control and plug it, that's so I don't get myself confused by gases that are coming up through the charcoal canister, from the charcoal canister into the engine. So that's something that I might have done, and it's something we might do. I don't know about the data yet, but I don't want to get caught on that. Always keep, when you're doing this, always make sure that you keep to the symptom. Why is the car here? Why am I working on it? And don't get carried away with other things. Now, the one thing that I want to go down is we want to look at the code, and this is the rich code, the P0172, and we're adding or taking away 25% of the trim. So we have a large trim here. And if you look at the data in your freeze frame, when there's a real freeze frame like this where we've run our monitors, it's always a really good idea to pay attention to the freeze frame. The data in which the code's set. What's the RPM? What's the load? What's the temperature? Because that data happened more than once. As soon as this code tripped or it failed the DTC, this code generation was put in a pending condition. All of this data then has to come within 10% of the target when it first failed to run a second or third test on it. So the one thing you know by this data is this car failed in these conditions multiple times. Always pay, particularly when you got a good freeze frame and the codes haven't been cleared, really pay attention to what it's telling you, when it happened, what are my trims. So now we can come over and we want to look at the digital. Now, right now, my long-term trim is minus 46. That's a lot of trim, guys. I mean, that's a tremendous sum of trim for long-term to have. So I definitely have a problem. We're at hot idle right now. So now what we need to do is we need to come over here and we need to go to the sharpshooter. What I want to do is take long plus short, and we want to go ahead and we want to run both of these. So what we're going to do is we're going to start this, and what this is going to do is it's going to load the trim dynamically, the load against RPM. So let's go ahead and we just slowly pull away, and what you do is you just slowly increase your throttle. Oh wow, this problem is only at idle. Okay, so this is only an idle problem apparently, because we can see by the trim numbers there on our chart that this is all low throttle positions. Notice that this is at 20%, and above the 20%, like at 30, 40, I'm all green. So as I open the throttle up, always think about this. What happens when you open the throttle up? You lose vacuum. The throttle plate is opening and the negative pressure within the induction system drifts towards the atmosphere. I don't have as much vacuum to pull in the fuel, whatever that is. So we're getting extra fuel, and where are you getting extra fuel? At idle. So one of the things that I'm going to want to go do is we want to get the PIDs, and we want to look up the airflow rate. So if I look up the airflow rate, is what I want to do is I want to come over here, and let's make this bigger where we can see this. And we'll take the short term, we'll take, let's see. Take the TP right now. So we want grams. Now this is a 2.4 engine, so we're running at 2.8, 2.9, and I'm in gear. Now the rule is that if I have a 2.4, I'm at a hot unloaded idle, I would have very close to that position. So let's take this out of the gear. Let's put this in neutral and see what we've got. So now our air rate's moving around a little bit. It's definitely doing some surging, and it's probably because I have so much fuel getting into this engine right now. But basically, we're at 2.2 or so, and we're okay with that. So let's go back into gear, and now we'll see what we get in gear. But this is not enough difference from 2.4 grams per second hot unloaded idle to overcome the parasitic loss of the motor. I take in so much air, and that air is basically equivalent to the liter size of the engine. So if I had a 2.4 engine, I'm expecting somewhere 2.4, 2.6 hot unloaded idle out of gear. Well, 2.8 is close enough. I've got 32%. This is a good air rating, so that the air is being read correctly for the trim. The trim is a problem. So this has got something to do not with the air side, but with the fuel delivery side. So I want to do one more test real quick while we're here. And that's just to confirm what we already know. This is all green. But we want to come over here and we want to run a VE test. So we're going to go in and we're going to run the VE test. And it's hotter than that, so let's go up. And now is what we're going to be able to do is we're going to be able to just accelerate away. So we want to just start to roll into the throttle and open the throttle all the way up. And we're just going to run first gear. And as we ran first gear, we can see what we already know. That up here, we're all green, and do you see how the yellow trace is the actual report from the mass air sensor? The red is a theoretical. See how close they lay over and we're green here? That means that this mass sensor read the right amount of air. But we knew that. Why did we know that? We knew that because the fuel trims are all green. This is only at idle. This problem has something to do where when I have more vacuum, I'm able to suck in fuel. So one of the first things I probably want to do is to plug the purge off and make sure that none of this fuel is coming from the purge. Now that we know what we're looking for, let's go back to the shop and run some tests.
Okay guys, one of the first tests that I want to do when I've got extreme fuel trims is I just want to make sure that they're real and that everything is working. And the feedback system, which is the oxygen sensor, the wideband sensor, is reading correctly, and those trims really are making the exhaust correct. So we've gone ahead and we've put a gas analyzer onto this car, and we can see our gas is right here. And what I want to show you is I have 1.02 lambda. Now a lambda of 1.00 is stoichiometric. That means that the air-to-fuel ratios are correct. So this is 2% lean, not rich. But we can look at our scan tool data right here, and we can see where we're taking away 37, 38%. This is a huge trim takeaway, and it's only happening at idle. We saw that from our test drive. So now's what I want to do is I need to do a real quick test. The first thing I want to do is to disconnect the purge hose. Whenever you guys have any kind of fuel trim issues and they're at idle or really low throttle openings where I have a lot of vacuum, I want to get rid of the purge. I want to just take it and plug it, and then it can't get me confused. So let's go ahead and do that. we have the purge right here, and what I'm going to do is plug it. So now the purge is plugged. So now that we've got the purge plugged, we can see that we're at 33. We still have a large trim, and we're still a lambda of 2. So basically, we still have a problem, don't we? So this is not purge related. So now what I got to start to think is, where can I get fuel from? Where else can I get it? Well, if I've got any kind of fuel in the crankcase, I can get it that way. If the injectors were dripping, that would really affect my lambda out, and that might give me a problem. But I don't have any misfires, and I don't have any misfire code set, so I'm not sure what that would be. But there's some ways to do this so we can better dial in what we're going to do. So one of the first things I'm going to do is we're going to go get the probe out of the tailpipe, and I want to check the crankcase first. I want to just make sure there's no fuel in the crankcase. So let's go ahead and do that. So what we're going to go ahead and do is I'm going to take the oil fill off, and I'm going to hold the probe right over the oil fill. Now the target is anything below about 600 parts per million HC is okay, and anything over 600 parts per million, and then it depends how much over, starts to become a problem. So let's go ahead and take a look at this. Now we can see the HC racing up. 2, 3, 4, 6, 7. Oh well, it's higher than 9,000 parts per million on the front display. So let's go ahead and take that out, and let's see how high it really is. So we can look at our data right here, and this will read to 40,000 parts per million. So if we go to measure and we get the data, we can see that this guy came all the way up, and basically it's quite high. So we're about 11,000 parts per million. Now, if I have 11,000 parts per million hydrocarbons are raw gasoline, guys. How did we get a bunch of gasoline into the oil? So that would be my question. And I would say the first thing that comes to my mind is the high pressure fuel pump is leaking. On many of these DI cars, these pumps can make up to 3,000 PSI. It's a lot of pressure. If I just get a little leakage, that leakage gets into the oil, and I get a problem like this. The other place that's way less likely, but I'm going to show you how to test for it, is maybe an injector's leaking. And if an injector was leaking when we shut the engine off, I would be able to see the gasoline in the cylinder. So before I take any plugs or anything else off, I'm going to put the probe back in the tailpipe, I'm going to shut this engine off, and I'm going to wait 5 minutes. The reason you're waiting 5 minutes is I need the catalytic converter to totally cool off. I don't want the catalytic converter to be above 700 degrees where it could help those hydrocarbons combust. So what we're going to do now is we're going to kill the car, we're going to put this in the probe, we're going to wait 5 minutes, and then we're going to do a cranking start test. If we have high hydrocarbons in the tailpipe exhaust, they come way high. When I first crank the engine, the injectors are leaking, they're dripping. And if those injectors drip into the chambers, and then I start to crank the car over, all that gasoline is going to get pushed out the tailpipe, and you're going to start to see something with more than 1,000 to 5,000 parts per million out the tailpipe during crank. That tells me I have too much gas in the cylinder. Now I would want to go and check the injectors with the gas analyzer. I can do that by pulling air out of each cylinder, and I can figure out which one is bad. But again, I don't think that's what the problem is on this car. I think we have a high pressure fuel pump leaking. But right now I just want to rule out that these injectors could possibly leak. So let's go ahead and get the probe in the tailpipe and wait 5 minutes. Okay, this car has been turned off for about 10 minutes now. That allows the catalytic temperature to get below 700 degrees. So if an injector was dripping into the cylinder, as soon as I start to crank it over, those hydrocarbons would not fire and they're going to be pushed out the exhaust. When they push out the exhaust, we have a gas analyzer set up to where we can catch that reading. And if we have something that's, 4,000 or 5,000 parts per million, we know that we've got an injector leaking into this engine. If we have good readings, then we know that that didn't happen. So this is really to just double check those injectors. Now that we're all set up, let's go ahead and start this car up. Okay, first off, it started really easily, which tells me that we're not that rich. But what we're going to do is we're going to confirm it. What we want to watch right here is the hydrocarbons. But we also want to watch the CO and the CO2. Now, if we watch the hydrocarbons, basically we have got up to 140, not very much. The CO also stayed low. CO2 came up and the oxygen fell. Now remember that the oxygen is reacting with the hydrocarbons are the gasoline, and then they're going to change into the CO2 and the CO. So HC converts with oxygen and makes CO2 and CO. So we can go over here, we can take the measure, we can get the data, this is our data. We can also go over and we can go to statistics and we can update the statistics. So the maximum amount of hydrocarbons is 203, and we had real good conversion on the CO. CO2 is high and the oxygen was high and dropped. So this is telling me that we didn't have any excessive gasoline dripping into the cylinder. So I don't see where an injector has got any kind of a problem. Therefore, what's going on with this car is the high pressure fuel pump is leaking. Let's take a look at that. This is the high pressure fuel pump right here. It's driven by the camshaft. So the cam is driven at the front of the motor and the motion comes back. As the cam rotates, it puts that mechanical force into this high pressure pump, and this high pressure pump converts it into high pressure fuel. So the gasoline's pressure can be boosted up to 2,700 to 3,000 pounds of pressure. Now under heavy loads, we get really high pressures in the pump, and that can give you a leak internally since the camshaft is rotating and moving this pump. This is oil lubricated. So when that gasoline leaks out, it leaks into the oil. So basically this pump has a leak and it's leaking that gasoline into the oil base. This isn't that uncommon for GDI engines. I see this from time to time occur. Now we've diagnosed this Chevrolet, and we can see that it's just not that hard to find this problem. This is a rich running car because we're taking away fuel trim. And when I say rich running, was it rich running? No, it wasn't. It had a stoke or lambda of 1. That's because the feedback system sees the additional fuel coming out of the crankcase through the PCV valve, and what's going to happen is then it's going to change or alter the fuel delivery into the engine, and it corrects that factor. So we had a correction happen. So when we say it's rich, it's really not rich, it's lambda of 1. The feedback system functioned and worked. The 40% plus that we have on trims to correct this problem, well, we could say that that's the window. That's how much we had to move to keep it in stoichiometry. Stoichiometry is where the weight of fuel and air are correct, and it accomplished that. So we can see that by driving this car and doing some basic scan tool techniques and gathering data and then making the next decision based on that data, where we're going to use the gas analyzer and then we're going to check the oil base and to check if an injector leaked, it really is pretty simple to diagnose a car like this. If you follow these simple, logical steps and use a diagnostic-driven plan to where you do a diagnostic and it drives your next test, you too will be successful in your service base.